So we've talked about our vision, our hearing, but what about our other senses? That's what we're going to focus on today. Sensory integration, vocab word you should know. Right? Sensory integration is the organization of various senses from one's own body in the environment. So pretty much it's how you use your senses in the environment you surround yourself in. Smell, right? Smell has a fancy name called olfaction. Make sure you remember that, right? So smell is a chemical sense. If you remember, we talked about before how your thalamus processes all of your senses except for smell, and we're going to see that here, right? So, like I said, it's a chemical sense. Your olfactory receptor cells, you have a tiny cluster of 5 million cells at the top of each nasal cavity, right? That's a lot of cells. If you've ever like got a cut inside your nose or a pimple inside your nose, you know how much it hurts. That's because it's so sensitive, right? 5 million cells each nasal cavity. That's a lot. So what happens is these cells they wave back and forth, responding to certain molecules, and instantly alert the brain through axon fibers that make up the olfactory nerves. They connect to the olfactory bulb at the front of the brain, which then connects to the temporal lobe and the limbic system. All right, so this is the only one that doesn't go through the thalamus. But one of the key things that you should know is olfaction, right? Smell is called olfaction. That's why you use your olfactory nerves connected to the olfactory bulb. So that's a word you're going to definitely need to know. So we talked about like highlighting notes. It's definitely something you want to highlight. What are some facts about olfaction? Um, One, odors evoke memories and feelings because they're tied to the limbic system. Right, so this is the more primitive areas of the brain that deal with emotion. So we talked about how memories are sort of different, all different parts of your brain. The main part of your brain for new memories is the hippocampus. But because if you smell something, that's going to trigger a memory, right? So like let's say you smell like a perfume or cologne, it also reminds you of like an ex-girlfriend or boyfriend, right? And then that brings up memories. Or maybe you smell cookies being made, and that reminds you of like grandma's cookies. Or let's say you smell pine, and it reminds you of Christmas, right? So smell, has a very strong tie to memories because of that. Sensory adaptation for odors occurs within a minute as we become about 70% less sensitive to it. So we talked about sensory adaptation earlier in the unit. That's what this is saying, how you just get used to stuff, right? And you don't even realize that's there. So you might walk in the room and it's, oh my God, what's that smell? But within a minute, you barely smell it anymore. Women have a better sense of smell than men. So for whatever reason, women tend to have uh, better senses than men do. We talked about how men's vision and or especially hearing kind of goes away earlier than women's do, and especially when women are pregnant, they become like super smellers. The olfactory function decreases with age, especially after age 65. So about half the people that were surveyed said that their smell went down after 65. And then at 80, about three-quarters of people said they couldn't smell as well at around 80. Taste, right? Once again, taste is a chemical sense. Make sure you know it is called gustation, right? So it's very important that you know taste is gustation and olfaction is smell. So you have these receptor cells found in taste buds called papillae, are located primarily on the tongue and inside the mouth. All right, so papillae is a vocab word you should know. So papillae are the receptor cells in taste buds. So it gets a little confusing. Each taste bud has around 50 receptor cells. All right, so it has about 50 of these papillae in it. When activated, receptor cells and taste buds send neural messages to the thalamus. Remember, the thalamus processes all of your senses except for smell, which then send these to different areas of the brain to process. So once again, a couple key vocab here. Make sure you know gustation means taste, and that papillae are the receptor cells found in taste buds. Taste bud and receptor cells. So each taste bud shows a maximum sensitivity to one particular taste. So, you have different taste buds throughout your mouth. Well, certain taste buds are for like salty foods, certain ones are for sweet foods, certain ones are for sour foods, and so forth. And I'll show you a little map of your tongue and how it's broken down. You have five tastes. This is important. You need to know all five tastes. There's salty, there's sweet, there's sour, there's bitter, and there's umami. Umami is like this rich protein taste, kind of like Parmesan cheese, like a strong Parmesan cheese is umami. And there's research going where they might name a sixth one. The umami is one they've named. That's the most recent one that scientists have said, oh, this is a taste. They've talked about another one as well. We'll see if it actually comes to be an official taste or not. Now, certain things like people think like hot and spicy, especially spicy, that is not a taste, right? That's a flavor. And so really, that is like when you have spicy foods, those are like pain receptors, all right? Damage to damage to taste receptor cells are replaced within a few days. So if you've noticed, if you've ever like damaged your mouth because like you ate something hot, especially like liquids or cheese, because that's a good conductor that'll hold the hotness for a while. So you might burn your mouth like eating pizza or something like that. If you notice it'll grow back within a couple of days. Even people like I remember my little sister when she was little, like bit her tongue. I think there's a hole in her tongue, and it grew back in a couple of days. Some people, if they get pierced, you take it out, it can grow back. So here's kind of that map I was showing you. You can see at I guess the back of your tongue would be the bitter, sour. You got salty on each side, sweet up front, and then umami in the middle, which is actually evenly distributed throughout the tongue. Paul Ekman's infant facial expression experiment. So Paul Ekman, we'll talk about him again when we talk about emotion. We have a motivation emotional unit we'll talk about. But he did, stuff with taste and expressions. So body expressions are cultural, but facial expressions are biological. So how you use your body, and we'll talk about this once again with emotions, that's a cultural thing. Different cultures express themselves differently with their body. But facial expressions, that's biological, meaning that's nature, right? Everyone around the world is kind of born with the same facial expressions to show their moods. And so what Paul Ekman did, he did an experiment with newborn baby and how their expressions changed depending on what they were given. So when he gave them water, they had no expression at all. When they gave them something sour, then they had the pucker face. You ever see like a little baby like get that pucker face? You kind of close your eyes. I guess we all kind of get that if you have something too sour, right? You got the bitter taste, rejection, right? Try to take it out of their mouths. Poisons are usually bitter, so we have a natural aversion to them. So throughout, especially think about like more than 10,000 years ago when humans were hunters and gatherers, anything that's bitter, if you drink anything that's bitter, like if you drink coffee or something like that, no one likes that originally, right? That's an acquired taste. So anything that you drink, usually it's drinks or eat that's bitter, we don't naturally like that. And that's because in nature, things that are bitter tend to be poisonous. So that's our natural, I guess, defense mechanism to not like bitter foods. Where like fatty foods we tend to love because that's what we needed to survive off of. Now that we live in civilizations like we do, we can get as much of whatever as we want, but we still crave those fatty foods. That's why we tend to be overweight nowadays because we're still craving those sugars and those fatty foods that we needed to survive, which was rare to get thousands of years ago. But now when you're in a civilization and you can go to the store and buy as much of it as you want, it's we still crave that and we tend to eat too much of it. Sugar, right? When sugars had baby, they had a pleasant face. Even when they put it in the amniotic fluid and found babies suck more and suckle earlier, right? So sugar is very addictive. They say it's more addictive than drugs, actually. So the last one he did was salt. This one doesn't actually develop right away. It actually takes a few days before babies develop an expression to salt. And this is one of the things as you get older kind of goes away. So I know some like elderly people and they put a lot of salt on their food because this is one taste that kind of goes away for them. So some taster facts. Once again, women are more likely to be super tasters, especially when they're pregnant again. So I remember like my wife when she was pregnant and other women, they actually didn't crave food like like you see in TVs a lot. They actually had more aversions because everything had such a strong taste to them. It was actually more foods that they didn't want to eat than they actually were craving. Taste receptors reproduce themselves, so if you burn your tongue, they come back. Age, though, causes number of taste buds to decrease. So this is what I was talking about earlier. When you burn on food, usually it comes back right away. As you get older, they don't come back as much, so, and you start to lose some of your taste. That's why I was talking about how some people I know who are 70 plus, they put a lot of salt on their foods because they've kind of lost those taste receptor cells. Alcoholics tend to be non-tasters. So alcohol and tobacco actually kills taste buds permanently and prematurely. So, I mean, another great reason not to be an alcoholic. I love food and I love the taste of food, so I want to, taste my food. So people who and smoking, I mean, two of the things you definitely don't want to do, become addicted to. Lots of reasons not to do it, but one is you can't taste your food, which to me is a very important part of my life. So once again, alcoholics and people who smoke cigarettes, use tobacco, tend to lose taste buds permanently and prematurely. Sensitivity to taste changes with age, so the number of taste buds deteriorates as we get older. A lot of times you realize like maybe you could start having spicier foods as you get older because you kind of lose those taste buds. That's why it's kind of a cultural thing. Certain cultures have hotter foods. Um, but you also tend to like different foods. So I know my kids stuff they ate when they were 2, they won't eat now. And like there's things that I'll eat now that I wouldn't eat growing up. And maybe that's because my taste buds have changed. Maybe I just gave more foods a chance as I got older. Don't know. But they do tend to change as you get older. Women develop more taste buds with puberty and lose taste buds with menopause. So we talked about menopause. So as you go through puberty, gain those hormones, you tend to become better tasters. With menopause, you stop the menstrual cycle, you tend to lose those taste buds. The Starburst experiment. So we usually do something similar to this. If we're in class, we'll see if we're out of class. I do the same thing, but I do it with Skittles. So what happens is you give someone a Starburst and you have them unwrap and eat it with their nose plugged and eyes closed. They won't be able to tell you the flavor, but they will know the taste is sweet. When they unplug the nose, they can tell what flavor. And this is because, and this is an important part, right? This is because taste is a bottom-up processing. Remember, we talked about top-down and bottom-up processing. While flavor is top-down processing because it involves the brain making a decision based on sight and smell as well. So when you taste something and you have no expectations, you can only taste the like the flavor. So sorry, I got cut off a little bit earlier. So just to finish up what I was saying is if you taste something without any expectations, you're only going to be able to tell the taste of it, right? So whether it's salty, sweet. But then if you can see it or smell it, we use, this is the whole sensory integration. We use our other senses to be able to tell, oh, that's grape or something like that. All right, so then our third sense that we haven't talked about is touch, right? So touch receptors are on the skin. Skin is the largest and heaviest organ. Make sure you know that. A lot of people don't realize that. You have 4 basic skin senses, and make sure you know these 4, right? Pain, warmth, cold, and pressure. So all your skin sensations are some type of combination of these 4 basic senses. So once again, skin is the largest and heaviest organ. A lot of people don't realize it's an organ because it's on the outside of your body. We always think of organs on the inside. And you have 4 basic skin senses: pain, warmth, cold, and pressure. And so everything that we feel is some type of combination of those 4. So what purpose does pain serve? Pain is actually your body's way of telling you something is wrong, right? It tells you to change your behavior immediately. Any external stimulus that can produce tissue damage can cause pain. Internal stimuli like disease or infection can also cause pain. Certain areas of the body are more sensitive than others. So a lot of times we're like, oh, pain is a bad thing. No, pain's actually good. It lets you know that something's wrong. There are certain people out there that don't feel pain. They might break a bone or cut themselves severely where they might bleed out, but they don't know because they don't feel pain. Even if it's something on the inside, right? If you have pains like in your stomach or something like that, that lets you know that something is wrong and that you need to do something about it, whether it's take medicine or go to the doctor. Those of you that seen the show Good Doctor, that was in one of the episodes um, in the last season where this person didn't feel pain, so she didn't realize that I think it was her appendix was bursting, and so she ended up having I think septic shock or something like that because of her appendix breaking. So sensitivity to different body areas of the brain. So these areas are the most sensitive: the back of the knee, neck region, bend of the elbow. The least sensitive is the tip of your nose, the sole of your foot, and the ball of the thumb. So can we distract ourselves from pain? The answer is yes, right? An athlete who's injured doesn't realize it until after the game is over. So if any of you guys are athletes, you kind of know what I'm talking about. You've probably been injured in a game, but you have all the adrenaline going. You don't even realize it. So I still remember the last football game I played in high school. Ended up separating my shoulder and tearing a ligament. I didn't even realize it. So I played like half the game, the second half of the game with this. It wasn't until the end of the game, I'm like, this is pretty sore. And then I take the shoulder pads off after the game, and you can see where the shoulder was separated. It wasn't dislocated, but it was separated. You could see like by the collarbone, that bone that sticks up, you could see it separated, right? But I played the rest of the game and didn't realize it because you distract yourself from the pain. Emotions and cultural differences can influence the brain's decision on opening or closing gates. So, there's a whole gate control theory of pain, and pretty much what this is saying is so your different cultures. So certain cultures say you need to block off pain, and so that's what we do. So pain is a lot of it's a mental thing. It's also like a neurotransmitter thing, but a lot of it's mental where you can kind of close those gates off like you don't feel pain. And so certain cultures say they emphasize blocking that pain, and so or not expressing your emotions as much, so they tend not to feel the pain as much. So a person's mental state can influence one's experience of pain. There's four main ways that we use to distract ourselves from pain, so to make pain go away. First thing is distraction, right? You focus on a non-painful stimulus. So if you had something happen to you and you're in a lot of pain, a lot of times someone will talk to you and try to distract you, get your focus on something else. Imagery, right? Create a vivid mental image can help control pain as well. Right, so we start to you try to imagine something going on, very vivid, and that will distract you from the pain. Positive self-talk, right? Oh, it hurts, but I'm okay, right? So what you do, you redefine pain. This is common if you're like working out, right? So if you're working out, those of you that's worked out seriously before, you understand that it can get painful, right? Your muscles, you're pushing your muscles to the limit, but you redefine that, right? You just say, pain is just weakness leaving the body, and you keep pushing yourself and you keep going. And the last thing you can do is relaxation, right? So you take these deep breaths and relaxing. It's one of the things to think about, like when a woman's giving birth, right? They go through their breathing techniques. So relaxation is another one. If you panic, usually it makes it worse. So relaxation can also help with pain. So the last part is we're going to talk about body position and movement. This is your kinesthetic and vestibular sense. So two vocab words you want make sure you want to know. So the kinesthetic sense, the system for sensing the position and movement of individual body parts. So make sure you know that, right? So it relies on receptor cells from the muscles and joints. So one's leg falling asleep is a disruption of your kinesthetic sense, right? So if your leg or arm falls asleep, that's just lacking blood flow to it. So what you do, you want to get blood flow going back to that leg. So you got to get up, you got to move around. Like if your arm falls asleep when you're sleeping, which can be very painful, especially if the whole thing falls asleep, you can't even move it. You got to take the other arm and take it and move it. Well, you pump your fist, that gets blood flowing. So that's all that really is. So that finger weighs a ton. So what you do, there's a little trick. So what I want you to do is put your middle finger down, like you see in the picture, and put the other fingers flat on the desk. You can't lift them up. What I want you to try to do is wiggle all your fingers. Notice that you can't wiggle your ring finger. If you do it, like it hurts, like it's very hard to do it. The other ones you can move easily, but that one you can't. Does anyone know why? The reason is because your middle finger and your ring finger actually share the same tendon, right? So they're connected. So it's kind of blocking it from lifting it up. Your vestibular sense, right? This is the system for sensing body orientation and balance. So make sure you know the difference between kinesthetic and vestibular sense. Vestibular sense is all about balance. This monitors your head's and body's position and responds to changes in gravity, motion, and body position. So how does this happen? There's equilibrium produced in the inner ear in the fluid-filled semicircular canals and vestibular sacs. The fluid moves when your head rotates or tilts. So these hair-like receptors inside are stimulated by this movement and send messages to the brain. So if you remember when we talked about the ear and hearing, right, we talked about the semicircular canals you can kind of see in the pictures, and I'll show you another picture in a second, and the vestibular sacs. So when you spin around in circles, you know, that fluid is spinning, those hair-like receptors are sending messages to your brain that you're spinning around in circles. Well, when you stop, your eyes tell your brain that you've stopped moving, but yet in your ear, that fluid still goes for a little bit longer, and that's why you get dizzy and nauseous. And this is the picture that I was showing you, right? So if you remember that snail-shaped thing that's the cochlea, if you remember, and these are the semicircular canals and the vestibular sacs within them. So that's just a blown-up picture from that. All right, so vision also plays a role, and this is what I was just talking about, right? So when visual information conflicts with the vestibular system, one can get dizzy, disoriented, and nauseous. Right? So like I was talking about how when your inner ear is telling your brain that you're moving in circles, but your eye isn't. Now that's confusing your brain, and that's why you get nauseous and dizzy and things like that. So lastly, there's an activity. Let's see if you guys can do this. What I want you to do is stand on one leg and balance. Pretty easy, right? Get up and do it now. All right, it's not that hard to stand on one leg. Now what I want you to do is close your eyes and try doing it. Don't peek. All right, did you start to fall over? You know, was it more difficult? And that's because of vision. We've talked about this before. You know, vision is your most dominant sense. So like spinning around and stopping fast causes the fluid and receptor cells to continue moving for a few seconds, tricking the brain into thinking you are still spinning. That's what I'm talking about with the other one. So it tells your brain that you're still spinning, but yet your eyes say that you're not.